All right, welcome back, math friends. So we're reading today from Math for Trades. This is chapter 7, the basics of fractions. What exactly is a fraction anyway? Have you ever dealt with fractions in either your schooling or your work? Well, a fraction is a part or portion of a whole. Say you ordered a pizza, and there were a total of 8 slices. You were hungry that day, and you had 5 of them, therefore eating 5 out of the 8 slices. That can be represented as a fraction. Here we have a fraction, and you read this 5 out of 8. Defining a fraction. Our story of fractions begins with Abigail, Hannah, and Naomi, who are electrical apprentices going through their schooling at the same time, who hope to open a company together once they get their red seal electrical tickets. We'll start with a couple of definitions. Every fraction has 2 parts, the numerator and the denominator. Let's take a look at a fraction to define each. And here we have 1 over 3, or you might say 1/3. The numerator, the number above the line in a fraction. It indicates how many parts of the whole are being counted. Denominator, the number below the line in a fraction. It indicates how many total parts are in the whole. If Abigail, Hannah, and Naomi did end up owning a company, each would own 1/3 of that company. Each person represents one owner, and together there are 3 owners in the whole company. Here are a few more examples of fractions. So here you have 1/2, 3/8, 5/16, 4/9, 7/15, and 77/145. Mixed numbers and improper fractions. The examples above are all of typical fractions, but we don't always see fractions in that form. There are 2 other styles of fractions that we deal with: mixed numbers and improper fractions. Mixed numbers. Let's say the 3 apprentices get together one night to talk about the future, and they order 2 pizzas, each with 8 slices. See here, ham and pineapple, and a vegetarian pizza. I know the pizzas look exactly the same, but you'll have to trust me on this one. One thing for sure is that each pizza has 8 slices, and someone has gone ahead and had a taste test of both pizzas. We need to break this down. We have a total of 2 pizzas, each with 8 slices. That makes for a total of 16 slices. If the apprentices eat one whole pizza, they will have eaten 8 out of 8 slices. So you see here, 8 over 8 is 1, or you could say 8 over 8 equals 1. Now let's say that one of the 3 of them has another slice from the second pizza. They will have now eaten one whole pizza plus one slice. That's 1 plus 1 over 8 equals 1 and 1/8. This is our mixed number. This is what is known as a mixed number. A mixed number can be defined as the following. Here, a mixed number, a combination of a whole number and a fraction. Next, we cover improper fractions. Improper fractions. A fraction in which the numerator is larger than the denominator. What this means is that the number on the top of the fraction is larger than the number on the bottom. We'll stick to our pizza example. Together, the apprentices have eaten a total of 9 slices. This accounts for one whole pizza plus one slice from the second pizza. Written as an improper fraction, the number of pizzas eaten would look like this, and that's 9 over 8. Now, we want to change a mixed number into an improper fraction, and then do the reverse, and take an improper fraction and change it back to a mixed number. Change the following mixed number into an improper fraction. This is our example, 1 and 3/4. Step 1. Change the whole number into a fraction, with the denominator being 4. So here we write out 1 is equal to 4 over 4. Step 2. Add the two fractions together. Now, we'll have to jump ahead a little here, as we haven't covered adding fractions yet. I'll give you the cheap and easy version here. As long as the denominators are the same, we're all good. When adding fractions, we simply keep the denominators the same and add the numerators. We'll go through adding fractions thoroughly in the next chapter. 4 over 4 plus 3 over 4. We add the numerators, and that gives us 7 over 4. So 1 and 3/4 is 7 over 4. Another way to find your answer would be as follows. 1 and 3/4 is, and here what they have shown is you can take the denominator following the arrows. 4 times 1 plus 3 is equal to 7 over 4. 4 times 1 is 4, plus 3 is 7, and the denominator stays the same. That may look a little confusing, but follow me through it. With the mixed number 1 and 3/4, take the 4 and multiply it by the 1, then add 3, and you end up with 7. It's the same answer, just a different way of getting there. Try going from a mixed number to an improper fraction by yourself. Here we have practice question A. Change the following into an improper fraction. Check the video answer to see how you did. So we have 3 and 3/8. And I'll keep going here. Alright, hopefully you've got the mixed number to improper fraction calculation down. But what about the reverse? We should go through an example of that as well, and then give you a chance to work through one yourself. So our example, change the following improper fraction into a mixed number. 27/6. Step 1. Find out how many times 6 goes into 27. We can do this using long division. The good news here is that we already went through long division in the first chapter. If you need to review it, take a look back to see how it's done. So they've taken 6, divided into 27, and we know that 6 goes into 4, 24, 4 times, with a remainder of 3. So our mixed number becomes 4. Notice we take the 4, that's the whole numbers. We have 3 remaining and 6 in our numerator. Try another practice question. We'll change the following improper fraction into a mixed number. Check out the video answer to see how you did. And this is 17/3. Brain break. Take a couple moments to review what you just learned before moving on. Take a moment to rest, and we will go to reducing fractions. Before we move on to adding and subtracting fractions, we should touch on another concept known as reducing fractions. Reducing is what we do when we want to make a smaller version of a fraction that still has the same mathematical value as the original. Back to our pizza. Once again, we have 8 slices per pizza. Now, say we eat 4 of those slices. We have eaten 4 out of 8. That's 4 number of slices eaten, 8 number of slices in the pizza, 4/8. If someone asked you how much pizza you had, how would you answer? Would you say, I had 4 out of a possible 8 slices? Or would you say, I ate half the pizza? I think we'd all agree that we would just say that we ate half the pizza, as 4 pieces would amount to half the pizza. If we were to write half as a fraction, it would look like this, 1/2. We could then conclude that the two fractions represent the same thing mathematically, and they are just two different ways to represent the same thing. You could look at it this way. I cut 2 pieces of wood. One is 12 inches in length, and the other is 1 foot in length. They are the same length. Their lengths are just expressed in different ways. So in the end, we end up with this. 4/8 is 1/2. What we've done is reduced the fraction from 4/8 to 1/2 without changing the actual value represented. How this was done mathematically is we took the original numerator of 4 and divided it by 4. What is done to one part of the fraction must be done to the other. So We also divide the denominator of 8 by 4, resulting in a fraction of 1 over 2. So it'll look like this. Notice what happened. They divided top and bottom by 4. To get 1/2. Doing the same thing to both the numerator and the denominator guarantees that the original fraction and the final fraction are equal in value. We reduce fractions when we can evenly divide the same number in both the numerator and the denominator. In our example, 4 can be divided into both. Note that the number 2 can also be divided into both the numerator and the denominator. If we divided both by 2, we would get 2 over 4. So notice, instead of dividing by 4, 4 over 8 is divided by 2 in the numerator and the denominator. Although this still works mathematically, we often want to get a fraction into its lowest terms, meaning to a point where it can no longer be reduced. The fraction 2 over 4 could be reduced even further to 1 over 2. So there is further work we could do if we choose to. Example. Let's go through the thought pattern when reducing fractions. Take the following fraction and reduce it to its lowest terms. We have 8 over 12. Step 1. What we want to do here is take a look at both the numerator and the denominator and determine if there is a number that can go into both of them. It might be easier if you write down numbers starting from 1 and then decide which numbers can go into both 8 and 12. Okay, so we find that 1, 2, and 4 can divide into 8 and 12. But 3, 5, 6, 7, and 8 do not divide into both 8 and 12. From this, we can conclude that the largest number that can go into both 8 and 12 is 4. Step 2. Divide both the numerator and the denominator by 4. In doing so, we obtain 2 over 3. There you have it. The fraction has now been reduced to its lowest terms. Always take a look at the answer when you are done, just to make sure that there definitely isn't another number that can go into the numerator and denominator, as this would mean the fraction could be reduced even further. The example shown above is fairly straightforward. Once there are larger numbers involved, it is sometimes easier to work through the question in a couple of steps to slowly reduce the fraction. Take a look at the following example to see what I mean. Example. Reduce the following fraction into its lowest terms. 24 over 168. Step 1. Determine if there is a number that can go into both the numerator and the denominator. If there is more than one number, then use the larger number. This is a bit tougher than the first question, as the numbers are a lot larger and harder to work with. Going back to our times tables, we can see that 6, 8, 12 all go into 24. We could also say that 24 goes into 24. But what about 168? What goes into that? One thing we know for sure is that 2 goes into both. So why don't we start by taking each part of the fraction and dividing it by 2? If you have trouble dividing 168 by 2 in your head, go ahead and use your calculator. And so they show us here division by 2, and we get 12 over 84. Notice each are whole numbers, but we apply them together in the numerator and the denominator. Step 2. Determine if the fraction can be reduced any further. We can see that, once again, we can divide both numbers by 2. And this is now 6 over 42. Step 3. Repeat step 2 and determine if the fraction can be reduced any further. What we note this time is that 6 can go into both 6 and 42, so we divide both the numerator and the denominator by 6, and we get 1 over 7. 42 divided by 6 is 7. 6 divided by 6 is 1. This is a really good strategy by dividing by 2 that I often use myself. If you get two numbers that are relatively unknown, is divide by 2 if it is even. Okay, there you have it. We have reduced that large fraction into its lowest terms in just a few steps. I will admit that if we had used a calculator for this whole procedure, we could have come up with the answer with less work. But that's not the point. Doing it the long way starts to train your brain in the relationships between numbers. As you get more familiar with numbers, you will be able to pick apart patterns and understand the relationships formed in math. Although it might be a little more time-consuming in the beginning, the payoff as time goes by is great. Practice questions. Try a couple questions for yourself and check the video answers to see how you did. Reduce the following fractions into their lowest terms. Question 1, 15 over 18. And question 2, 24 over 36. And this concludes our section on the basics of fractions.